Hello class, this is a video tutorial on the examples of extension trig identities part 2a. In this video we'll be applying the product identities. If you haven't watched the proof of these identities, you don't really have to, but a quick way to remember these is as follows. Sine A, sine B, cos A, cos B, these are the same. Sine, sine, cos, cos. To remember this, if they're the same, it's always because. Why are they the same? Because. And for both of them, notice how the A minus B is first, A plus B is second, and the only thing that's different is the sign between them. If they're different, sine A cos B or cos A sine B, it is sine. You can think of it as it's a sin to be different. Just as before, they're both A plus B to begin with, and then A minus B, and the only thing different as well between them is that one is addition and one is subtraction. So I hope that helps you remember these. So let's actually go into it and apply them with these questions here. So let's write each as a sum or difference of trig ratios. This is very straightforward. We're just going to take this expression here and express them as the correct identity. So let's take a look here. Cos 2x sine 5x. That's cos and then sine. That's cos A sine B. Hopefully you can see that connection there. So that is cos A sine B. From here, I can express this as half outside of. Since they're different, I know they're going to be sine. And for both of them, it was addition first, and then subtraction afterwards. And the only thing I need to double check is, since it's sine, cos and then sine, it's going to be a subtraction in between them. Now from here, we just simply place in the values. So A is 2x, B is 5x, and likewise for this one here as well. That's 2x, 5x. Simplifying this, it's nice and simple. We get half outside of sine 7x minus sine, that's going to be 2 minus 5, that's going to be minus sine of negative 3x, which, using some further trig identities, is going to be sine 7x plus sine of positive 3x. Okay, let's move on forward. Hopefully you saw that that wasn't too difficult in applying the product identities. So let's move on and apply it to the next one. Sine 6a sine 2a. That's sine sine. It's going to be this one here. So it's going to be equal to half. Since I know they're the same, it's going to be cos and cos, and for the cosine, it's always going to be A minus B, A plus B. The only thing I need to try and remember is that subtraction for sine, so minus here. Now instead of A and B, it's going to become 6A minus 2a and 6a plus 2a. That's going to give us half outside of cos 4a minus cos 8a. And I'm just going to leave it at that there. Okay, let's keep moving forward. Let's take a look at these next two here, sine and then cos. Okay, so if they're different, I immediately know it's going to be sine and sine. With sine, I need to keep practicing this as well. It's going to be plus and then minus. So plus and then minus, and it's going to be a positive in between them. Now, instead of a and b, it's going to be 3x and 8y, 3x, 8y. And unfortunately for us, we're just going to leave it at this. So let me just make it nice and neat. Half sine of 3x plus 8y, sorry, close bracket, plus sine of 3x minus 8y. And there we have it. You could then expand this further using the sum of sine and the difference of sine, but that's for a different video, and we'll leave it at this. One last example. I know they're both the same, so it's going to be cos. So cos a minus b, cos a plus b. I need to try and remember if it's plus or minus in between. Double check. Cos, it's a plus. So it's going to be plus in between. Now once again, instead of a and b, it's going to be the values shown here. It's going to be 4y minus y and 4y plus y. Simplifying this, we get cos of 3y plus cos of 5y. And we'll just leave it at that. So I hope that gave you an insight into how we can apply the product identities to expand given expressions. So I hope to see you in the next video. Best of luck.